What's up YouTube? My name is Johnny Bannon with Intrepid Technologies, and today is video 8 of our Confluence EIGRP how-to series here at Intrepid Technologies. So if you've been following my other videos, you know that we use Confluence and we go over the how-to pages that I've created there under my company Intrepid Technologies. So please click that link below and let's do it. Alright guys, so today we will not be going over OSPF authentication. Today is video 8 of our EIGRP series. So we're going to be going over EIGRP over Dmvpn. So of course, we all know what Dmvpn is, right? It's a hub-to-spoke topology using the next hop router protocol to have multiple tunnels all talk to each other, multiple spokes using the tunnel interface all talk to each other across the internet. So, for instance, I can have a router in Phoenix, Arizona, and a router in New York, router in Seattle, Houston, all over the country, right? One of those routers can be designated my hub router. Then all those spokes connect to it via GRE and an interface tunnel. And then it looks like they all have direct connections to that hub. And then that Dmvpn hub is going to route traffic to all the spokes. So let's say we create this Dmvpn and we use EIGRP as a routing protocol. Like all distance vector routing protocols, EIGRP has some route loop prevention mechanisms embedded in this technology. One of those is split horizon. So what split horizon does is that it doesn't allow an interface that received a route to go out that same interface. So if we go back to our topology here, R3 is my hub, and then all my spokes are R2, R1, R4, and R5. If R4 sends its loop back via EIGRP to this hub via interface tunnel 0, it can't send that same route back out interface tunnel 0 to all the other spokes. So the inherent problem with this is that these spokes won't know about each other's routes. Only router 3 will know all the routes from these routers. So what do we do to fix this? Well, there's a couple of different things we can do. We can implement phase 3 Dmvpn, and what that does is after initial communication with the next hop server using NHRP in Dmvpn, we can actually create a spoke-to-spoke tunnel in phase 3. So instead of always going to the hub like we do in phase 1 Dmvpn, we just go straight to that spoke. Now I know I just threw out a lot of acronyms at you guys, but this video is supposed to focus on EIGRP. So all the Dmvpn jargon that I'm using will be in another series and different how-tos that Intrepid Technologies will be creating. So stay tuned. So what we do right now to fix it through EIGRP is actually simple. We actually just shut off split horizon on that tunnel interface. And what that'll do is turn off that mechanism that doesn't allow routes that are received on the interface to not be sent out that same interface. So this fixes the problem I just described. So now let's actually get started on some configuration. First thing I'm going to do, guys, is download my repo I use for all my at-home labs, and that project is called CCIE Enterprise. And I do source control management using Git, and I like to actually use VS Code to do all my Git. So I could do this on the command line like I showed you in the last video, but here I'm actually going to, let's remove this folder, get rid of this. So what I'm going to do is actually clone that Git repo. So first thing you do is go to the repo, clone with HTTPS. I'm going to go through this kind of quick because on all my videos I do the same thing. So if you're struggling with these concepts, just go back to my original EIGRP videos or stay tuned for a specific video series on Git. Let's open up the folder I just cloned. Actually, we'll do it this way. From Johnny Home, CCIE Enterprise. Should be right here. All right. And as you guys know, I have role-based folders using Ansible to actually create my base configs. But if you don't, you can actually just use that repo on your own labs and actually paste these configs in yourself. Let's get rid of all this. Now let's go to GNS3. I'm going to bring this over. And like I've described in my other videos, this is the topology I use for all my at-home training as well. And when I do these videos, I don't change anything. And I want to show you guys how easy it is using my baseline and the applets I've made in there to go from OSPF to BGP to EIGRP all in one day using the same lab and the same network topology, right? If we go back to Confluence, it says we need a baseline. So this is the config, but let's actually baseline these commands using an applet. And I'll show you that applet real quick. I try to do this in every video just so in case you're jumping around in the video series, you still have some essay on what's going on. So I'm only going to be using routers 1, 2, 3, 4, and 5. Because those are all the ones connected to my Dmvpn cloud, right? And this is just actually a switch. So now that I've consolated into all those, let's do a base configuration. So I type in an alias called baseline, and then another one called interfaces. These applets are all the same on these routers. And what they're doing is getting rid of any routing process. Then the interfaces one is putting back all the interface configurations. All right, sound good, guys? So we're going to go through on all the routers and do this now. We'll do this on Houston. Interfaces. Do it on Phoenix. And this would actually be our hub right here, so remember, keep that in mind. I think we still have Miami to do. Let's just check right here. Houston, Seattle, and we have Houston. We actually have, I think Denver still left to do. We'll make sure as we go along. So routers 1 through 5. Yes, Denver, we still have the baseline. So since this lab is specifically going over Dmvpn and EIGRP, one thing we should do, guys, take a look at our network topology, and all these physical interfaces connecting these routers to each other, we're actually going to turn off because we just want EIGRP traffic to go between these routers. So we'll go to R4 and shut down gig 0 and gig 2. We'll then go to Phoenix and we'll shut down gig 02, gig 03, and gig 01. So we'll go to Seattle and to Phoenix. Shut down the interfaces that are physically connecting these routers. Because we want to make sure we're just getting routes through the tunnel. And if we didn't do this, we wouldn't have any routing issues because these physical interfaces will actually be preferred over the tunnel just due to the metric, the EIGRP metric. And you won't actually see the tunnels not advertising the same routes they received out the same interface because you'll just see the routes coming in via these physical ports. Let's go ahead and do that. So I said we'll go to Seattle, do show IP interface brief. We want to shut down gig 0 and gig 02. Those are physical addresses connecting the other routers. Then we want to go to the Phoenix router, do show IP interface brief. And we want to shut down the same ones, the physical ones going to the other routers. So that's 01 through 3. Shut. Okay, guys. So since the main focus is your EIGRP, I'll just briefly go over what these Dmvpn tunnel interfaces look like. So we'll do show run interface tunnel 0. So keep in mind this is R3, the hub. So what we have here is just a couple IP and HRP map commands, which we need. Some authentication for the actual DMVPN. All these have to match. The tunnel key, network ID, and the authentication all have to match within the DMVPN between all hubs and spokes. Then we have this key command here, tunnel mode GRE multipoint, which actually creates or tells that tunnel interface it's going to be dynamic multipoint. Then if we go to the spoke and look at its tunnel interface, this will be the same on every single router that's a spoke. The tunnel's actual IP address, right? We have that on both. The authentication, all the same as you can see. Then the important commands. This telling it that it's going to be multicast dynamic, so a Dmvpn. And then right here we have the IP and HRP map command. So what is this actually telling us? IP and HRP map. It needs the IP destination. That'll be the hub's tunnel IP. So we tell it, hey, for this tunnel, the destination is this IP address. But how do we know how to get there? Because we're also going to tell you that destination's NBMA address. It's non-broadcast multiple access address. What this is the actual physical interface connecting that router to the internet. So we need to make sure we have routability here first to the NBMA address before any tunnels come up. And then we have this IP and HRP map multicast. So what that is telling it is to send all multicast traffic to this NBMA address. And then it's all the hub's IP address schemes, right? And this is the same on every spoke. And then we have to give it the next hop server address, which is not the NBMA address. It's actually the tunnel IP. So IP, next hop routing protocol, next hop server, IP address. And this is the configuration for phase 1 Dmvpn right here. All right. So now one thing I like to do before we start actually doing any EIGRP configuration, let's go to our repo, and I'm going to grab a TCL script that I made that pings all the tunnel interfaces to make sure that we actually are pinging before we start doing any routing configuration. And already we got some issues, right? So it looks like we can't hit router 1. So I'm going to go into router 1. Looks like we can't hit router 4. Let's make sure we have no routing protocols running still. So we still have BGP, so that baseline didn't actually work. So I am going to have to fix that on this router. That's okay. So we can't get to router 4. We can't get to router 1. Let's just make sure there's really no routing protocols running. Just NHRP, that's good. Let's look at our interfaces. So it looks like we should be up on everything, right? That's what it tells us. The tunnel's up. The NBMA address is up. Let's go over here to Phoenix. Make sure that its NBMA address is up and up. Great. So let's try pinging the hub's NBMA address. Okay, so maybe we didn't get an ARP going between them. And now let's actually ping the hub's tunnel IP address. 5.1.0.3. Still no bueno. So what we're going to do here is I'm just going to flap this tunnel real quick. Then we're going to go to R4 and do some troubleshooting now. So let's ping the NBMA address, because we can't even start troubleshooting the tunnel until we make sure that we can reach the actual physical address, okay? Now let's try the tunnel. If this doesn't work, we'll do the same thing we did on the Houston router. Flap that tunnel, shut, no shut. Let's try that ping one more time. Boom, now we're there. Do the same thing on R4. If you're looking for an explanation on this, I really can't give you one. It's just a troubleshooting step I do in GNS3. But tunnels sometimes will need interesting traffic to come up. That's usually more of an IPsec thing. But now we're good. So let's run that TCL script one more time. We can ping everywhere. All right, guys. So now let's go back to our Confluence page. Look at our steps. Bring this up. So now we're just going to configure named Eogrp, then look at a spokes routing table and see that we're not getting any routes, or all the spokes routes in this routing table. All right, too easy. So let's go back to GNS3. Again, we're working R1, 2, 3, 4, 5. Go to VS Code. I actually have named Eogrp right there. Awesome. We're going to run this to all the routers that were in our topology currently. I know this may look messy on the screen, but we'll just go through it one by one. So first one up, Miami. We'll paste named Eogrp, exit out of there. We'll do Phoenix next. Paste named Eogrp. We'll minimize this one. Paste it here, paste it here. So let's actually just work on the Houston router and our hub router. Let's bring this up. Sorry for all the clicking, guys. I'm trying to make this look good for you on the screen. All right, so let's take a quick breather, right? So what did we do? So we already have configured Dmvpn. We made sure that only the Dmvpn network is up right now. We made sure that we can ping the MBMA, and then we pinged all the tunnel IPs from the hub. We're running phase 1 Dmvpn, and now we just configured EIGRP to advertise all the routers' routes, all the active networks. Okay? So now we're going to go to one of the spokes, and we're going to see if we're getting all the routes from our other spokes, all their networks. So show IP route EIGRP, and look, we're only getting the hubs. That's no good. So before we turn off Split Horizon, let's make sure that the hub is getting all the routes, and it is. It's getting every route from every spoke. So if I tried to ping, let's say 155.1.45.1, we'll source it tunnel 0, nothing. We can't reach it. And of course we know that because it's not our routing table. So what we're going to do is we're going to go into tunnel 0. We're at the hub now. We're turning Split Horizon off at the hub. Type in no IP Split Horizon EIGRP and our autonomous system number, which is 1. We should see a resync of the EIGRP neighbors. Okay, just give it a second here. Let's make sure that that was our actual autonomous system number. Yes, it was. All right, we should have seen a resync of our neighbors, but let's just check the routing table, one of our spokes. Still nothing. Let's check our EIGRP neighborship. Okay. Let's go back to this Confluence page and make sure that I'm actually doing it correctly. So let's actually go under name mode and do this, guys. So my fault, but that's why we're here, right? We're learning together. So I'm going to actually go back into interface tunnel 0, undo what I just did, IP Split Horizon, EIGRP 1. Yep, that's why it didn't work, because we're using name mode. So awesome. Let's go into name mode and make this change then. Easy way to do this, do show run pipe section router. Copy paste. Go into the tunnel interface from named EIGRP mode. And this is the good thing about named EIGRP, right? Everything is under this one interface, way more modular. So no split horizon. And now we see the resync. Okay. Let's come here and now check our routing table, show IP route EIGRP, and boom, look at that. Now we got all the routes, guys. So before we go, let's look at some other things on the hub. So here, we can actually see some Dmvpn stuff. So show Dmvpn detail. Here we can see all of our MBMA addresses, the state, how long it's been up, its target network, right, which is just the tunnel address. We can actually look at some NHRP stuff, show IP NHRP, tunnel 0. And we can see all the peers here. So that's just some troubleshooting show commands for Dmvpn. All right, guys. So that's all I have for today for Dmvpn over EIGRP. Remember that split horizon is a routing loop prevention mechanism that doesn't allow a route that router learned on the same interface to be advertised out that same interface. So in a Dmvpn topology, we obviously see the innate error in that the hub routes all traffic via that one tunnel interface. So if we're using named EIGRP, we need to turn split horizon off under the EIGRP named process, right? Command being AF interface tunnel, whatever number, and then no split horizon. So again, guys, thank you for viewing this with me. And from everyone here at Tripa Technologies, remember to keep learning every single day. Thank you.